Hi everyone, welcome to my channel. This is Quantum Unicorn. The LeetCode problem we are solving in this video is number 350, intersection of two arrays 2. In the world of programming, LeetCode is a popular platform that challenges us with various coding problems. The intersection of two arrays 2 problem is one such challenges that tests our ability to find the intersection of two arrays while preserving the frequency of each common element. Well, actually, I have previously made a video for this LeetCode problem, and today I am going to solve it using a different approach. But before we jump into the code, let's understand the problem statement. Given two integer arrays, nums1 and nums2, our goal is to find their intersection, considering that each element should appear as many times as it shows in both arrays. Throughout this video, we will dissect the code line by line, exploring the syntax, mechanism, algorithm, semantics, and logic behind each solution. By the end, you will have a solid grasp of the approaches and be ready to tackle similar problems with confidence. How exciting! Let's get started. The intuition behind solving the intersection of two arrays 2 problem is to find the common elements between two arrays, considering the frequency of each element in both arrays. So to achieve this, we use the counter class, which allows us to count the occurrences of elements in a collection by creating two counter objects, one for each array. We can count the frequency of each number in both arrays. Then we iterate through one of the counters and check if each element exists in the other counter. If it does, we calculate the minimum count of that element in both counters. This minimum count represents the number of times the element should appear in the intersection. Finally, we add the current element to the intersection list, the corresponding number of times, by extending the list with the element repeated count times. The key insight in this solution is that by using the counter class and the min function, we can efficiently determine the intersection of two arrays while considering the frequency of elements. This approach ensures that each element appears in the intersection as many times as it shows in both arrays. The time complexity of the given solution is O of m plus n, where m is the length of nums1 and n is the length of nums2. This is because we iterate through each array once to count the frequencies of the elements. Iterating through counter 1 takes O of m time, as it has at most m unique elements. For each element in counter 1, we perform a lookup in counter 2, which takes O of 1 time on average. This is because dictionaries, which counter is based on, have a constant time average lookup. And extending the intersection list takes O of minimum of m or n time. As we add the current element a number of times equal to the minimum count between counter 1 num and counter 2 num. Returning the intersection list at the end of the function does not contribute to the time complexity. Therefore, the overall time complexity is O of m plus n for this solution. The space complexity of the solution is O of m plus n as well. This is because we create two counter objects, counter 1 and counter 2, which store the frequencies of elements in nums1 and nums2 respectively. In the worst case, these counters can store all the unique elements from both arrays, resulting in a space complexity of O of m plus n. Additionally, the intersection list will store the common elements, but its space requirements are limited by the maximum number of unique elements between nums1 and nums2. Therefore, the space complexity of the solution is O of m plus n. Let's break down the code step by step. First, we import the counter class from the collections module. Okay, sorry. The counter is a container that allows us to count the occurrences of elements in a collection. We will use it to count the frequency of numbers in both nums1 and nums2 arrays. Here we define a solution with the method intersect. The method takes in two input parameters, nums1 and nums2, both of which are lists of integers, and this method should return a list of integers. And these two lines create two counter objects, counter 1 and counter 2. We pass the respective arrays nums1 and nums2 to the counter constructor. These counters will store the frequency of each number in the arrays. And this line initializes an empty list intersection, which will store the elements that appear in both arrays. Here, we iterate through the elements in counter 1 using a for loop. For each number, we check if it exists in counter 2. If it does, we calculate the minimum count of that number in both counters using the min function. This count represents the number of times the element should appear in the intersection. We then extend the intersection list by adding the current number num repeated count times. This is achieved by multiplying num by count using the asterisk operator. Finally, we return the intersection list, which contains the elements that appear in both nums1 and nums2 array, which with each element repeated the minimum number of times it occurs in both arrays. By using the counter class and the min function, we efficiently calculate the intersection of the two arrays while considering the elements' frequencies. All right. Here is the solution I made in the previous solving intersection of two arrays 2 video. Let's call it solution 1 and call the new solution in this video solution 2. The main differences between the two solutions are the data structures used and the way they handle the counting and comparison of elements. Solution 1 manually implements a dictionary hash map using a regular Python dictionary and retrieves counts using the get method. It performs explicit checks for element existence and non-zero counts. It keeps track of the results in the result list. And solution 2 utilizes the built-in counter class, which provides a convenient way to count the occurrences of elements in a list. It directly creates two counter objects for nums1 and nums2. It compares elements between the counters and calculates the minimum count. The intersection elements are stored in the intersection list. Overall, solution 2 with the counter class is more concise and leverages built-in functionality, while solution 1 implements similar functionality manually using a dictionary. Alright, that's all for today. I hope this was helpful. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.